This is the lesson on Chapter 3, Section 2, where we're going to solve systems of inequalities through graphing. In Section 3-1, we solve systems of linear equations using graphing, using substitution, and using elimination. Now we're going to solve systems of inequalities using graphing. We're also going to determine coordinates of different intersection points or vertices on a shaded area, on a solution area for systems of inequalities where there could be three or more equations or inequalities. So the process for solving systems of inequalities would be, first, let's graph each inequality separately and shade the correct area, and then we're going to identify which of the areas, so that should break it up into different sections, and which area would be shaded in common for both of the inequalities. So if you look at where you overlapped the shading, that would be your solution to the system. So here, this is the system of inequalities we're going to use for our first example. We have y greater than 2x minus 3 and y greater than or equal to 2x minus 3 and y less than negative x plus 2. So when we graph y equals 2x minus 3, and then since it's a greater than or equal to, we shade above, kind of if we shade it in yellow, above this solid blue line. And then for y less than negative x plus 2, well, this dotted line represents negative x plus 2. And since it's a less than, we would shade below in kind of a blue. And so region 1 here in yellow is only shaded by the 2x minus 3. Region 3, that's in darker blue, is only shaded by negative x plus 2, but this area in region 2 is shaded by both. Not only is it below the negative x plus 2, but it's also above the 2x minus 3. So this area, region 2, is our solution to the system of inequalities. No longer are we interested in just the point of intersection, but we're interested in the intersection of the shaded regions. The intersection of those regions is region 2, which is the solution of the system. Notice that the solution is a region containing an infinite number of ordered pairs, unlike a system of equations, which is just one ordered pair. Here, I'll let you take a minute, pause the video, and solve this system of inequalities by graphing. Which one would be the correct answer for the overlapping shaded region? Okay, so let's go over what you should have had as an answer. All four of the equations have lines that are the same. So the borders for the shaded regions is not going to be the issue. 3x minus 3 is this guy. X plus 1 is that guy. So, and they all have the correct one dotted. The x plus 1 is dotted each time. So we just have to look at where the shaded area should be. The less than or equal to means that we're going to be shading below on the 3x minus 3. So below on the 3x minus 3 should be over here. Over here. Over here. And over here. See if I can mark on this. Oh, there it went. Okay, so if we want below the 3x minus 3, but we want above the x plus 1. Well, above the x plus 1 is up here, below the 3x minus 3 is over here, And so this whole area would be shaded maybe in yellow, this whole area would be shaded maybe in blue, and this whole area, this little sliver right here, would be shaded blue and yellow and might make green. And we'll try this one. Pause the video. Go ahead and graph these, see what you get. Okay, so if you'll notice, if you recognize that these two graphs have the same slope, so the shaded borders of the borders of the shaded area are going to be very similar. So if we look at the graphs, we have negative 3x plus 1, and we need to shade above because it's a greater than. We have negative 3/4 x minus 2, which we need to shade below because it's a less than or equal to. And so if you shade below this one and above that one, and they're parallel, which means they'll never meet, then there will not be any area in common. They will not overlap. So the solution has no points in common, and so there'd be no solution would be your answer, or empty set. Pause the video again, pick A, B, C, or D. Okay, so if you shaded below the 1/2 x plus 4, and you shaded above the 1/2 x plus 2, shaded above that one and below that one, then in between is where they would overlap. Now, D and A both show the same shaded area, so to figure out which one is the correct answer, the difference is these are dotted lines and these are solid lines. So don't miss the fact that these are strictly greater than, strictly less than, and should be dotted lines. Here we have a word problem where we need to create two inequalities, and then look at the shaded area. Patients that have a cholesterol level C, which is below 200, and a triglyceride level of T, which would be below 150. That's recommended levels. So if we want to write a system of inequalities to represent the range of acceptable levels, C would represent cholesterol levels, and so C must be, it's going to be greater than 0 but less than 200. And then T would represent triglyceride levels. It must be less than 150, but it's going to be bigger than 0, so between 0 and 150. And so if we look at what that looks like, well, on a graph, we would need to create a graph, and so everything less than 150 triglyceride, everything less than 200 in the cholesterol level. So everything in this shaded area would be acceptable and be the solution. Let's try this one. Read the problem, write two inequalities, and graph the system of inequalities that would represent this situation. Here are your choices. Here's the problem again. Category 3 hurricane, wind speeds of 111 to 130 and storm surges of 9 to 12. That's what we classify as a Category 3. They would have wind speeds in that range and storm surges in that range. 111 to 130, 9 to 12. So storm surges of 9 to 12, 9 to 12. This looks more like 9 to 14. This looks more like 6 to 14. This looks like 9 to 11. (111) to 130 would be right in here. Be between those two and between those two, and so this squared area in the middle would be our solution. Now the next thing we have is the coordinates for vertices of a triangle area that's formed by these three inequalities. So what we would want to do is graph all three and maybe use three different colors and figure out where they are all three shading. What area is overlapped by all three? Not just two of the three, but all three. And that area, we want to look at the vertices that corner that area. So what we might need to do is, we're going to do it by graphing. This is what it looks like. We shade below, and you'd probably have to get these in slope-intercept form first to make this work out and figure out what these look like. Or you could set each one of these up and do every combination to find the intersection points between any two. Where do these two intersect? Where does the first one and third one intersect? Where does the second one and third one intersect? And so you may want to use substitution or elimination, or you can still go back to slope-intercept form and try it in the calculator. But we need to find the intersection between every combination of these three. So between the 2x minus y equals -1 and the x plus y equals 4, those two would intersect at the point 1, 3. The x plus y equals 4 and the x plus 4y equals 4 would intersect down here at 4, 0. The 2x minus y and the x plus 4y equals 4 would intersect down here at 0, 1. So we would shade below that one, and above the x plus 4y equals 4, and that would give us this area shaded by all three. And the vertices of the triangle would be 0, 1, 1, 3, and 4, 0. Find the coordinates of the vertices of the triangle formed by these three inequalities. Let you pause the video a minute, work this problem out, figure out which one is your correct answer. One method for doing this is to take each inequality and maybe pretend like it's an equation so that you can put it in slope-intercept form. Change x plus y equals 3 into y equals -x plus 3. Negative 2x plus y equals 3 becomes y equals 2x plus 3. And then, so you've got 1, 2, 3 equations. And then in your calculator, where does equation 1 and 2 intersect? Where does equation 1 and 3 intersect? And then where does equation 2 and 3 intersect? So on your calculator, if you use the calculator to help you do the intersection, we put in 1 and 2, we'd have -1/2 x plus 1/2. We'll put that in y1. So -1/2 x plus 1/2. And then in y2, we'll put number 2, which is y equals -x plus 3 and then let's look at the graph between those two, and we can do a second trace 5, enter, 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 and those two will intersect at the point -2, 5. Or actually it's the point 5, -2. So then if we take the second equation And the third equation, so the negative x plus 3 and the 2x plus 3, okay, so I'm going to remove this one and put in negative x plus 3 and 2x plus 3. Look at their graphs. I think I know where they're going to intersect. They both have a 3y intercept. So second trace 5, yeah, 0, 3. So that'll be the intersection between lines 2 and 3. And then last, I want to find the intersection between lines 1 and 3. So I'll take out the negative x plus 3 and put in the negative 1/2 x plus 1/2. Their intersection would be negative 1, 1. Now, just for fun, we could come up with, actually have the calculator show us the triangle and the shaded area. If I go back in and put the inequality symbols the way they, instead of my equal signs, then that'll show me where I need to shade. So I'm going to shade above the negative 1/2 x plus 1/2, below the negative x plus 3, and below the 2x plus 3. So I'm going to put all three of these into the calculator at the same time. Now, when I want to make the calculator shade as if it's an inequality, I can arrow over to the left of the y1, and if I want it to shade above that line, then I can hit enter until that's going to make the line thicker. That's going to make it shade above the line, which is what I want, but I'm going to go through the rest of them. That'll make it shade below the line. That'll make the line draw with a bubble as it draws it, leading the way. That will make it not draw the line, but just make a bubble go along the line. And that makes it a dotted line for less thans and greater thans. And that's back to normal, so it toggles through all of those. We want shade above. For this one, we want it's y less than, so we want shade below. There's above, there's below. And for y3, we want shade below also. So the first one's shade above, the second one's shade below, the third one's shade below. So here's what it looks like on the graph. There's shaded above the 1/2 x plus 1/2. There's shade below the negative x plus 3. And there's shade below the 2x plus 3. So this area right in here, so we can zoom in. This triangle area, now I've gone out a little bit too far, shows us the triangle shape. So this would be the point negative 1, 1, I guess. Let's see what it does when I do second trace. First curve, second curve, but it's hard to tell. Okay, because it can't see the intersection point, so scratch that. We'd have to zoom back out again. But it's too hard to see when it's shaded that much anyway. So the method we went through is the best method. Is take two at a time find the intersection and find all combinations of intersection, and then look at what area is shaded. All right. Good luck.